Welcome to Regular Expressions 101. Today we're going to dive deep into one of the most powerful tools in text processing. Regular expressions, often called regex or regex, are powerful programming language for working with text. They might look intimidating at first, but by the end of this presentation, you'll be comfortable creating and using them in your own projects. Let's begin our journey into the world of pattern matching. In this course, we'll work through a carefully structured progression of concepts. We'll start with the basics and build up to more complex patterns. By focusing on these key objectives, you'll develop both theoretical understanding and practical skills. The course is designed to be hands-on, so I encourage you to practice each concept as we cover it. Our journey through regular expressions follows a logical progression. We'll start with the fundamentals and gradually build up to more complex concepts. Each section builds upon the previous ones, creating a solid foundation for understanding regex. The course is structured to provide plenty of practical examples along the way. Regular expressions are like a specialized search language. Think of them as a way to describe patterns in text, much like you might describe a sequence of characters to someone. For example, when you want to find an email address, you're looking for a pattern, some characters, followed by an @ symbol, followed by more characters and a dot, and then a few more characters. Regular expressions give us a precise way to describe and find such patterns. They're incredibly powerful because once you learn the syntax, you can use them in practically any programming language. Let's start with the simplest form of pattern matching, literal characters. When you write a regular expression using just normal letters, it matches exactly those letters in the text. For example, if you search for cat, it will find exactly that sequence of letters. Notice how it won't match cat, because regex is case-sensitive, or cats, because we're only looking for exactly cat. This is the foundation of regex, exact matching, but we'll soon see how to make our patterns more flexible. Special characters are what give regex its power. The dot symbol is particularly useful, it matches any single character. So, C.T matches cat, cut, cot, or any other three-letter word that starts with C and ends with T. The caret symbol and $$ symbol are called anchors, they match positions rather than characters. The caret matches the start of a line, while the $ matches the end. When you need to match these special characters literally, you use the backslash to escape them. For example, to match an actual dot, you'd write \dot. Character classes are like creating your own custom any one of these matches. Think of them as a menu of acceptable characters. When you put characters in square brackets, the regex will match any single character from that set. The hyphen creates ranges, so AZ means any lowercase letter. The caret inside brackets has a special meaning, it negates the class, so caret 0-9 means anything except a digit. The shortcuts like \D and \W are just convenient ways to write common character classes. \D is the same as 0 to 9, and \W is the same as Z0-9 _. Quantifiers are how we specify repetition in regex patterns. They're incredibly powerful because they let us match patterns of varying lengths. The asterisk symbol is the most flexible, it means 0 or more of whatever comes before it. The plus symbol is similar but requires at least one occurrence. The question mark makes something optional. The curly brace notation gives us precise control over the number of repetitions. When we combine quantifiers with character classes, we can create very flexible patterns. For example, \D3 \D4 would match phone numbers like 555-1234. Groups serve two main purposes in regex. First, they let us apply quantifiers to multiple characters at once. Everything inside the parentheses is treated as a single unit. Second, they create captures that we can reference later in the pattern or in our code. Back references are particularly powerful. They let us find repeated text patterns. The \1 notation refers back to whatever was matched by the first group. This is perfect for finding duplicated words or matching HTML tags. Non-capturing groups give us the grouping behavior without the memory overhead when we don't need to reference the group later. Let's look at some practical applications of everything we've learned. These are patterns you'll use frequently in real-world development. Email validation is probably the most common use case. Notice how we can break it down into parts: username, @symbol, domain, and top-level domain. Phone numbers are another great example where we can use quantifiers and optional separators. The date pattern shows how we can enforce specific formats. With URLs, we handle optional parts, like the S in HTTPS, and variable domain names. When developing regex patterns, it's crucial to follow a methodical approach. Start simple and gradually add complexity. Always test your patterns with both matching and non-matching cases. Online regex testing tools are invaluable. They provide real-time feedback and help you understand how each part of your pattern works. For complex patterns, break them down into smaller pieces and test each piece separately. And always document your patterns. Future you will thank you. Let's talk about some common regex pitfalls and how to avoid them. Greedy versus lazy matching is a frequent source of confusion. By default, quantifiers are greedy. They match as much as possible. Adding a question mark makes them lazy, matching as little as possible. Overcomplicated patterns are hard to maintain and debug. Sometimes multiple simple patterns are better than one complex one. Performance can be an issue with certain patterns, especially when using backtracking. Be aware that regex implementations can vary between platforms, so test on your target environment. Performance optimization is crucial when working with regex, especially in production environments. Backtracking can cause exponential slowdown. This happens when the regex engine has to try multiple possibilities to find a match. Using anchors, caret and dollar, can help by limiting where the pattern needs to look. Being specific about what you're matching, rather than using generic patterns, not only makes your regex more efficient but also more accurate. For very complex text processing, consider using parsing libraries instead of regex.